Docker is super versatile, and in my opinion, everybody working in software development and machine learning should know how to use it. This is why I wanted to create a small series of videos explaining and teaching the relevant parts of Docker. This is the second video in a series about Docker. In the first video, I have shown what Docker actually is, how Docker is structured, and how it works. So if you haven't watched that video already, now would be a good time, because in this video, we will build on the foundation established in the last one. Hi, for those of you who don't know me, I'm Johannes Frey, but you can simply call me Joe, and I've been working as a software engineer for more than 10 years. I'm based in Stuttgart, Germany, and I am self-employed and run a company that does programming, data science, and DevOps, since at some point you also want to deploy your awesome machine learning model into production. As you maybe can see, I invested in some better lights for my videos to increase the quality for you. Please let me know down in the comments whether you think the quality is better now and what else I could improve on. I know I still look a bit excited and not that smooth in front of the camera, but I think this will get better the more videos I make. But enough with all of this blah blah, who I am and what I did. Let's get back to the topic. In the last video, we've established the basics about how Docker works. Now let's actually use it. The possibility to reuse Docker images that someone else created comes through another nice feature of Docker. Docker has the possibility to upload images to registries like, for example, Docker Hub, which is public and integrated into Docker. And there are many official Docker images for the bigger open source projects. But you also have the possibility to run your own private registry and push your images there if you happen to be in some enterprise or startup environment where you work on non-public projects. Let's try using an already available Docker image. So for this example, I've chosen to use the Spark Notebook Docker image. I've chosen this Docker image since it is related to data science and includes many different tools that you otherwise would need to install on your local machine. With this Docker image, they all come included and you don't need to install anything besides Docker. So to run this Docker image, you could copy this command from the page, which would then download the image to your local registry. But you don't really need to do that, since Docker will try to download the image from Docker Hub if it can't find it locally. We will therefore use directly the docker run command and not the docker pull command. Alright, that may look a little bit intimidating, but don't worry, you don't always need all those parameters, and they are very use case specific and specific to the Docker image that you're trying to use. But let's break them down. First, docker run specifies the command. Then the --rm tells Docker to delete the container when we are done running it. So this is some housekeeping. The next parameter is -p. And it specifies a port mapping. It tells Docker to map the port 4040 of the host to the port 4040 of the Docker container, basically making the port available outside of the Docker container, and then again the same thing for the port 8888. The parameter after this is -v, which bind mounts a volume, making the path from your host on the left side available as the path on the right side inside of your Docker container. The paths have to be absolute. This is why I use the pwd command to reference the current directory instead of just using the dot. The path inside the Docker image, so the right side of the column, used here is specific to this Docker image and will be different in your use case if you use another Docker image. And the last thing is the name of the Docker image we want to run. Additionally, you can specify environment variables with the -e parameter for your Docker container. So in this case, we introduce an environment variable called my_env and set it to the value of hoch. I would say that those are the most important parameters for the docker run command, and you can repeat them if you need to, as we've seen with the port mapping. But now, let's actually use it. We will start the Docker container and copy this path, paste it into our browser. Then I need to replace the IP with localhost. And here we go. Now, as you see, we see all the files from our current directory inside the work folder. This is what the bind mount does. this -v command that we've seen earlier. Now I can just go ahead and create a Python notebook and just print something. And it works. And now I can go ahead and save it as test, save. And now if I go back to the terminal, you will see that this file actually shows up in our local file system. And as I said, here is the newly created file. But we can not only use Python, but we can also use Spark with Scala. And again, without installing it to our local machine. So let's try this. Now I will just copy some commands from the documentation to initialize Spark in Scala. And now the actual command. As you see, the Scala interpreter is initialized, Spark is starting up and printing a result. So this is now calculated by Scala and Spark and all without installing it. So now we can actually go to the port 4040 and access the Spark console. If you remember, we added a port mapping for the port 4040 to make it available to our local machine and to the browser. I hope you enjoyed this short trip, and this is how you can use a Docker image. Now that we've seen how to use already available Docker images, what about building your own? I hope this video has shown you how awesome Docker is and that it is a pretty smart idea to elaborate it into your development process. I hope you enjoyed this video and have learned something. If so, it would be great if you would consider subscribing to my channel and going crazy on that like buttons and bell icons and whatsoever. See you in the next video, and in the next video we will talk about creating our own Docker images.